Welcome once again to my YouTube channel. Today we are going to look into an interesting topic in physics, quantum physics precisely. A topic, photoelectric effect, otherwise called photoelectric emission. We have a question on the board, but before we move into solving, let's highlight you on this very topic, photoelectric effect. Now I would want you to remember that metal behaves as a positively charged atom in a pool of electrons. Now, in order to remove electron on a surface of a metal, it requires an energy in order to do that, because the electrons at the surface of a metal is being pulled down by the negatively charged particle downwards. Hence, it will not be easy to liberate those electrons. Hence, it requires minimum energy in order to be liberated. And that minimum energy is what we term to work function. Take for example, if we have a metal, let's say that this represents a metal where we have electron, positive charge, negative charge, positively charged particle, positive charge, negative charge, positive, negative. So here becomes the surface of a metal. That's the metallic surface. Now, if you want to remove electron here, that energy known as work function is required. So that work function is equal to the binding energy, which is the energy that is pulling it downward, that holds it to the surface. So that energy holding this is equal to work function. That work function is required to liberate the electron. And the binding energy holds the electron to the surface. So in order to liberate the electron now, you need light. We have, for example, if here becomes the sun, we have the rays of the sun. Now, if this sun irradiates to this very surface, the sun has its energy, that's the energy of photons. We have it as HF, which is also equal to Hc over wavelength. I will recommend you to go to my YouTube and check on quantum energy. I treated this there. So now this very energy of light, when irradiated, will first conquer the binding energy, which is the work function. So part of it will now be used as work function. But if the energy is in excess, the energy of radiation here is in excess, then the remaining one, or the remaining part of the energy, will now be used as a kinetic energy of that electron. And that kinetic energy, which we know is equal to half mv squared, which is also equal to electron volts. Remember, electron volts is the energy required to accelerate an electron through a potential difference of 1 volt. So this implies that we have two parts of energy obtained from this radiation energy. So when the light falls on the surface, part of its energy is used as a work function, while the remaining part is used as a kinetic energy. And this very idea was brought about by Albert Einstein, where he states such in his equation that energy of photon, which is this very one, is equal to work function plus maximum kinetic energy. So this is Einstein's equation. The Einstein's equation. So from this, you can integrate all this. You can get a lot of formulas from there. Here is the photon's energy, which is equal to HF. Work function now becomes HF0. Now, at this very point, F naught here is a threshold frequency. That's the minimum frequency required to liberate electron from metallic surface when light of sufficient energy falls on the metal. So, we have it, plus kinetic energy. So you can still say that H, the frequency, is the same or has a relation with wavelength in this way. That's the wavelength of the light, the speed of the light. Now equals, we have H, speed of light, over lambda naught. Now this lambda naught means threshold wavelength. So threshold wavelength is the maximum wavelength required to liberate electron from its metallic surface. So we have kinetic energy. Of course, you know that kinetic energy is half mv squared. Kinetic energy can still be electron volt, like I said there. So here we can have HF equals Hc over threshold wavelength, kinetic energy, electron volts. So you can get as many formula as you could. We have Hc over wavelength equals H F naught plus, maybe you have half mv squared. So a lot of formulas. We have Hc over wavelength equals Hf naught plus kinetic energy. So all these are the same. Just master the formula, you'll be able to solve your exercise. So let's get to the question now. So solution to the question. So we have the given parameters. So they said the threshold frequency for a metal, 5.5 exponential 14. So we are given the threshold frequency as 5.5 exponential 14 hertz. Now, what is the work function for the metal? Now, the work function now becomes H times threshold frequency, where H is the Planck constant. So the work function now is equal, we have the Planck constant given in the question as 6.6 exponential minus 34. 6.6 exponential minus 34. Then times the threshold frequency. Now we have the threshold frequency here as 5.5 exponential 14. So our work function now becomes 6.6 times 5.5. Then times we have 10 from the law of indices. Please go and study your indices. Plus 14. So our work function now becomes, now you get your calculator. Let's solve together. So here we have 6.6 times 5.5. So we have 36.3 times 10 raised to the power minus 34 plus 14. Yes, it gives minus 20 joule. But we have to make this to be standard. That is, we have to shift this point to this very side. Hence, we have work function equals 3.63 times 10 raised to the power minus 19 joule. Please go and study your indices. Now, we've got the work function. So the next question there, that's exercise 2. They said if light of wavelength is 4.5 exponential minus 7 shines on the metal, calculate the maximum kinetic energy of the emitted photoelectrons. You know what photoelectron is? Yes, that is the electron emitted from the surface of a metal. when light of sufficient energy hits the surface. So that electrons liberated from the metallic surface is called photoelectrons. That's the light electrons. Electrons obtained from a metal surface as a result of light falling on the surface. Okay, so if the light of wavelength, we have the wavelength of the light given as 4.5 exponential minus 7 meter. Then calculate the maximum kinetic energy. So from Albert Einstein, here is the maximum kinetic energy. So any of the formula can go depending on the parameters you have there. So we are now asked to calculate the maximum kinetic energy. Then we have the wavelength. So the formula now, the maximum kinetic energy now becomes the difference between the work function and the energy of photons. Of course, I told you that photons energy, part of it is used as a work function, while the excess one is used as a kinetic energy. So that excess, which is kinetic energy, is the difference between energy of photons and the work function. Or rather, you make kinetic energy the subject, it becomes E minus work function. So here we have E minus work function. Although we've got the value of work function, then the energy here, which is energy of photoelectrons, where the wavelength is the energy of light, the wavelength of light has been given. So the energy of that light, which is photons. So the one we are going to use now will be, we have hc over wavelength minus the work function. So at this point, we have to do the substitutions now. So we have the Planck constant times speed of light divided by the given wavelength. Now we have the Planck constant given as 6.6 exponential minus 34. So 6.6 exponential minus 34, then times the speed of light, 3.0 exponential 8. So we have 3 times 10 raised to the power 8. All divided by the given wavelength, which is 4.5 exponential minus 7. Then minus the work function. Minus the work function. So we have to simplify this now. The maximum kinetic energy equals, let's solve this together. So we have 6.6 exponential minus 34 times 3 exponential 8 divided by 4.5 exponential minus 7. Then we have 4.4 exponential minus 19. Then minus work function. So the maximum kinetic energy now becomes 4.4 times 10 raised to the power minus 19 minus work function. We have the work function as 3.63 times 10 raised to the power minus 19. So if we solve together, we have 4.4 exponential minus 19 minus 3.63 exponential minus 19. Then we have the maximum kinetic energy equals 7.7 exponential minus 20 joules. And that gives the final solution to the given question. So if the lesson was able to help someone out there, please don't forget to subscribe, share and turn on notification for others to learn as well.